let's look at a couple kinematics graphs. Question 1 asks for which of these graphs has the greatest change in position during the interval, right? Greatest change in position during the interval, okay? Now, how do we figure out change in position through velocity versus time graphs? Well, we can do something called area under the curve. Basically, what area under the curve says is that you look at the area under the line or under the curve. So for A, let's say, it will be this right here. We find the area of this, and that will be the change in position for this much time, given the velocity that's increasing. Okay? Similarly, we're going to have area under the curve, area under the curve, area under the curve, and then area under the curve. Now, if we look at all of these, we can clearly tell that B is going to have the greatest area. Therefore, the greatest change in position during this particular time interval is going to be B. So B is our answer. Okay. Now, we can also, let me just write this down. When we're going from acceleration to velocity, or from velocity to displacement, okay, we can use area under the curve. When we're going the other way around, which is from displacement to velocity, and from velocity to acceleration, we can use slope. Okay, so just remember this when you're looking at graphs. All right. Number 2, when is the acceleration most negative? Okay, now if we look at this line right here, that is a positive slope. Therefore, okay, whenever we're looking at graphs first, let's look at our axes. It talks about velocity, right? Which means that if it's asking about acceleration from a velocity graph, we're going to have to look at slope. Okay, so slope right here is positive, okay? And it's asking for the most negative value. So this can't be our answer. Here, the slope is just 0. Here, it is negative, okay? So this could be an answer, okay? Here, it's positive again. And here, again, it's negative. So, which one's the answer? It's asking for most negative. Therefore, which of these two lines has a slope of greater magnitude? That would be this line right here, x to z. Because although this line is negative, this line is steeper. Therefore, it's more negative than this line. Okay, hope that makes sense. So, it's x to z. Oh. Sorry. All right. To the right is a graph of an object's motion. Which sentence is the best interpretation? All right. So, we're given a position versus time graph. Let's just do our velocity versus time graph and our acceleration versus time graph from this given graph. Okay, so this is a diagonal line. Therefore, we know our velocity versus time graph is going to be horizontal. And our acceleration versus time graph is just going to be 0. Okay? So, whenever you're going from displacement to velocity to acceleration, it's always going to be a curve to a diagonal line to a horizontal line to a 0 line. Okay? So, if this were a curve, let's use a different color. Okay? If this were a curve, this would have been a diagonal line, and this would have been a horizontal line. Okay? But since this is a diagonal line, we're dealing with horizontal and then 0. Okay? If this were a horizontal line, this would just be 0, and this would also be 0. Okay? So you can use this to help you when you're looking at graphs. All right. Option A. The object is moving with a constant non-zero acceleration. Okay, we just said that our acceleration is 0, so A is wrong. B, the object does not move. Well, we can clearly see a change in position. Therefore, the object is moving. C, the object is moving with a uniformly increasing velocity. Well, if we look at a velocity graph, it's just a constant line, so it's not increasing. D, the object is moving with a constant velocity. Yes, right? It's a constant velocity. So, D. Then E, the object is moving with a uniformly increasing acceleration. Okay, all right, that's not the answer because our acceleration is just 0. Next question. Okay. Here is a graph of an object's motion. Which sentence is a correct interpretation? Okay, our position versus time graph. Therefore, let's analyze this. So it starts off somewhere here, which is a positive value because it's above 0. Okay, now it continues to be at that particular position for a certain amount of time. Okay, then it goes from that positive position and it goes to 0. Okay, it goes all the way to 0. And then it continues to stay at 0. Okay, still at 0 here. Okay, so if we were to draw this out, something like this, I always like to look at it with a number line. So if this were 0, and this is our positive value, we can just assume that it's 8. Okay, let's say our object was right here, right? It stayed there for a particular amount of time, then it went from 8 to 0, and then it stayed at 0 for a particular amount of time. Okay, if this is clear, let's read our options. A, the object rolls along a flat surface. Then it rolls forward down a hill and then finally stops. Okay, no, this is not our answer because it mentions a hill. And plus it says that it's rolling along a flat surface. It rolls forward down a hill and then it finally stops. Okay, so everything else is correct. It's just that the hill part is wrong. Okay. And although this is kind of correct for a scenario, it's not exactly correct. Like, it's not concise. Okay? So, if it were rolling down a hill, then you would have some acceleration. Okay? Let's do a hill scenario real quick. So, acceleration, velocity, displacement. Okay? If we're going to have some sort of acceleration, velocity is going to be increasing, displacement is going to be a curve. Okay? Because we use this. So, we don't see a curve anywhere in this graph. Therefore, it's not rolling down a hill. Where else do we see hill in our options? So, hill, this is not our answer. Hill, this is not our answer. Okay? Let's read C and D. C, the object is moving at a constant velocity. Then, it slows down and stops. Okay, this is really important because it's talking about position versus time. If this were a velocity versus time graph, we would have chosen C. But since this is position versus time, C is not our answer either. So it's extremely important that you read your axes before you begin analyzing the graph. So C is wrong. And then D, the object doesn't move at first. Yes, it doesn't move. Then it moves backwards and then finally stops. Yes, that's what we said right here, right? So it goes from a positive value to 0 and then it stops. So D would be our answer.